Thanks. Yeah, so my name's Scott. I'm slightly ill and slightly hoarse, so I apologize for that. But if you can't hear, just kind of wave and I'll try and project a bit more. So I'm going to talk about Jupyter notebooks and collaboration. And there's several social and technical things we can do to improve this. I'm going to focus just on technical things today, because that's where I have a bit more interest and more focus on. So my name's Scott. If you've got any feedback or other suggestions, send me an email. So I work at ASI Data Science. We're a machine learning and data science consultancy based in London. And what that means is we write quite a lot of Python. We write quite a lot of Python in Jupyter notebooks. And we also work on some quite large and complex projects where we have cross-functional teams of both scientists and engineers. And these teams change over time, so we get people joining the project or leaving as it fits. So we have a quite strong interest in trying to make the workflow around version control and collaboration and Jupyter notebooks as easy, as seamless as possible. So just as a start, who uses Jupyter notebooks regularly in their work? Cool. So lots of you. So that's not super surprising. I think the Jupyter notebooks become like the de facto environment for doing data science, basically. That's because it's really well suited to these kind of exploratory workflows. So we can mix some prose that explains what our code's doing, written in Markdown, some equations, so we know the mathematical basis of what we're doing, along with our actual Python code, and then the output that comes out from that. So fairly specific to data science is that very often our output is not just like textual. We're not just executing code for its side effects, but we're making plots or visualizations or looking at some rendering of the data set to understand it better. And completely independently from the Jupyter notebook becoming super popular for data science, but across about the same time period, Git has become the de facto standard for collaborating and sharing on code. Especially fueled by the popularity of tools like Bitbucket and GitHub that have really led to a resurgence in open source software development, making that more accessible. And we also want to use tools like Git and version control for data science code, despite it being a more kind of exploratory field in a lot of senses than other fields of software engineering. And I think there's a few really important reasons for that. If you're going to do good data science, why it's really important to use version control. Firstly, we want our research to be reproducible. So often we're building a model or we're deriving a result that is actually going to be used by a business or another organization to have some effect. It's going to inform decision making. Maybe it's a bank who decide whether they're going to issue people with loans or not. So we want to be able to make sure this is reproducible so we can always work out what results we were offering at a particular time and be able to track the provenance of those results. So if someone comes to us and asks, why was this decision made, we know what code was used to run it, we know the version of the model, and we can give that answer with confidence. But finally, we also want to be able to work collaboratively in teams. So on larger projects, the lone data scientist working by themselves is not sufficient. Certainly, there's a huge range of skills in data science, and this idea of the unicorn, the data scientist who can do everything from Hadoop to D3 visualizations is not really very commonplace. So we want to work in teams of mixed skills, so people who have really good hardcore engineering skills, people who are more creative, people who are very good at communicating with the client. And this really means being able to share the work in our Jupyter notebooks. So maybe the first thing we try and do is just mash these two things together. So we commit all our Jupyter notebooks to Git. And firstly, this seems to work pretty well. You can just commit them, they're files, just like if you had Python source code. But anyone who's tried this and tried working in teams doing this will have found out that pretty soon you come across a bunch of friction when you're trying to do this. And this is a set of challenges that I want to talk about and how we might try and mitigate these challenges. So I think these challenges all stem from two fundamental things. One is that Git's design is not well suited to Jupyter's design intrinsically. So Git was originally developed by Linus Torvalds, the author of the Linux kernel, for that specific use case at first, so versioning the source code of the Linux kernel, so a bunch of C source file. So Git just sees files as a collection of lines, and it's not aware of any structure within those files. Whereas a Jupyter notebook, by comparison, is actually highly structured. So when you save a Jupyter notebook, it's saved to your disk to the file system as JSON. So there's strict structure in that file that spans multiple lines, and that file also contains a mix, not just of your Python source code, but also the output and some metadata. So there's a disconnect between them. So let's look a bit more visually about what that looks like. So this is a snippet of like a very simple example of maybe some rudimentary data science you'd do in a notebook. So we read in some data from a CSV file in the file system, we print a little sample of the data, and then we make a nice histogram of the temperature column. So for versioning and sort of our interest in the code, what we really care about are these green bits. So our input code in each case. But surrounding this and also stored in the file on the file system are this other stuff, highlighted in red. So on the left, we've got some execution counts that tell us which order the cells are running and how many times they've been run, and then the actual output that gets printed. And there's a couple of more interesting specific things about this data science example. So the top output is actually non-deterministic, so it's a random sampling of a data set. So every time I rerun this notebook, even if I don't change any of my input code, I'm most probably going to get a very different output. And secondly, the output at the bottom is non-textual. It's like a PNG or an SVG, an embedded plot, which Git isn't very good at dealing with. And the result is that if you open up a typical data science notebook, don't change any of the code, just run it again and save it to the file system, and then run git diff, you end up with an abomination like this. So this is in fact just that. I just pulled one of the notebooks we use from teaching materials at ASI, ran it, saved it, and looked at git diff. So none of the stuff that's changed here is actual code or things I care about. It's just all metadata changes. But if I were to look at this when I had made, changed one line of code, it'd be really difficult to understand what had changed. And if I want to collaborate with members in the team, it'd make it really difficult for them to review a pull request with all this noise. So I'm going to try and offer some really practical tips that hopefully you can make use of straight away. A combination of techniques and tools to make working with Git and Jupyter notebooks more fun, more efficient. So let's start off with the techniques, which don't require any previous karate experience. So the first one is the simplest one. It doesn't require any tooling, and a lot of you might already be familiar with it already. And that's git add-p. So when you want to stage a notebook to prepare it to commit, often you could just type git add and the name of the notebook. It'll be staged, and you can make a commit. And in this case, Git will take the whole file and all the changes and move them to the staging area. A small improvement you can make is if you call git add with the -p argument, it'll interactively, for each chunk of changes in the file, ask you if you want to stage them or not. So in this case, I have a notebook where I'm making a matplotlib plot, and someone else has made the plot with the default colors. My favorite color is red, so I go through the notebook and change every instance of a plot to red. So what I really care about is this diff at the bottom, where I've changed the color to red. But as a result, the image that is rendered in the notebook has changed completely. And because it's a binary image embedded in a notebook, Git just shows me the base 64 encoded output, which is meaningless. I can't read that gibberish with my eyes. But with git add-p, I can just say, no, I don't want to stage the change to the image, but yes, I'll stage the change to the code. So that's super simple. You can start doing that straight away. But what if in many cases we don't actually care about the output at all? Like I can regenerate the output from my code, and stored as text, that base 64 encoded image is not very useful. So another alternative we can do is to simply clear all the output from our notebook before we save it. So you can do this from the menu in the Jupyter notebook. The cell menu, click all output and clear. And the effect this will have is it'll remove all the execution counts and all the output sections from all the cells. And then when you look at the git diff, you'll just see the changes to the input code. And you can still use git add-p to just interactively select the chunks you want to stage for a particular commit. That helps you write really focused small changes that are easy for collaborators to review, which really helps with the workflow. So there's some tips you can start using straight away and don't require any tooling at all. But there's a couple of things that didn't cover. So for example, although often you might want to clear all your output, there are very definite use cases we have where we want to keep it. So nice examples are if you're writing documentation, so perhaps you've written like a visualization or a data analysis library and you're using Jupyter Notebook as like a documentation for users to use. In that case, you probably want to keep the output in so they can see the effect of the code that's going to be run. And secondly, for teaching materials, very similarly, you want teaching materials to have the result of the code that's going to be run so the students can understand what's going to happen. So let's move on and look at some tools that could help with this. So I mentioned earlier and kind of alluded to the fact that the Jupyter Notebook being JSON makes some of these working with Git difficult. But one of the great advantages of a notebook being JSON is actually really easy to manipulate programmatically compared to just a plain text file. So we can use that structure to manipulate the notebook programmatically and automatically. So the Jupyter Notebook out of the box supports something called file save hooks. So this is, the file save hooks live in a config file somewhere, and you can basically just provide a Python function, and every time you save a notebook, that Python function will be run on the notebook before it's saved. So you could do, your imagination is basically the limit with this. But you could, for example, use this to automatically clear the output every time you saved a notebook. So it would save you having to remember to go and do that via the menu each time. And this is a really simple example of a file save hook. So this lives in a Jupyter Notebook config that lives somewhere in your home directory probably. And I've written a function called remove output that receives the notebook. If the file it receives is a notebook versus another kind of file that Jupyter deals with, we just return. But if it is a notebook, then we iterate over the cells in the notebook. And if they're a code cell, as opposed to, for example, a markdown cell, we just reset the execution count to none and remove all the outputs by just setting the outputs to an empty list. So all I need to do now is hit Command S or click Save, and I'm automatically getting the output cleared for me. And then I just need to bind this to this configuration value in the config file. So that's nice. I don't need to manually go through and do it via the menu each time and I get my output cleared. But there are a couple of little annoying things about this, although it is super useful. Firstly, I've moved away from the slide now, but I'm sure a lot of you can't remember the path to that config file already. It requires finding that, which might be dependent on your system and like how you install Jupyter, for example, from Anaconda or from pip. And you need to paste that code in or try and rewrite it from memory. It also needs every collaborator to set it up manually. So if I'm working with a bunch of people on my team, we all need to configure our machines to do the same thing. And what is also a problem, especially, like I said earlier, if we're writing, as well as sort of data science code that we want to commit and is used on important projects, if we're also writing documentation and tutorials, if you use a file save hook, it's going to apply to every notebook you save and that user account on that machine. So you can't selectively choose this to happen in certain Git repositories and not in others. So there's some limitations with the Jupyter file save hooks. So at this point, let's think edit from the Git side rather than the Jupyter side again. Git has a lot of advanced functionality and some of it can be quite confusing. I think that's why we needed a plumber's talk yesterday to understand some of this. But some of that functionality can be very useful if you spend a little bit of time understanding it and thinking about how it can be useful to your use case. And one particularly useful piece of Git functionality is filters. So filters they don't seem to be super often used, but they're actually really useful. So filters are just a way to configure Git to say when you're checking a file out from a repository onto the file system, or alternately when you're going the other way and committing a file from the file system to a repository, run it through some arbitrary code that I provide to transform the file. And there's two kinds of filters. So the first one is the smudge filter. So this is a filter that runs when you're checking code out. For example, if you clone code from GitHub and then you check out a particular branch. And the nice thing about filters is, A, they're configured per repository, not per user. And secondly, you can configure them just to run on particular file types. So there's an example here. Say I've got a repository with 3 files in, a couple of text files and a Ruby file. I'm a Pythonista, so I don't know what to do with the Ruby file, so I just ignore it. I don't configure any filter for that. But for the text files, I can configure a little filter that perhaps converts tabs to spaces. And then every time I check out a text file, all the tabs will get converted to spaces automatically. So that's not really what we want here, though, for the Jupyter Notebook case. What we're interested in is the other kind of filters. So these are called clean filters. And they work in a very similar way to smudge filters. They just work in the opposite direction. So a clean filter operates on the file you have in your working directory when you stage it, and mutates the file that goes into the index for staging. So for example, for the text files here, I could do the inverse and swap backwards between tabs and spaces. So the clean filter is really useful here because we could use this to remove the output from the Jupyter Notebook every time we save it. So we can do that on a per repository configuration basis, and we can also just get it to run on Jupyter Notebooks. So we can tell that just from the .ipynb file extension. So a simple clean filter that would do that looks something like this. So the essence of the code is basically the same as the Jupyter file save hook we saw earlier, except now, rather than us receiving the notebook model to the function, we just read it from standard in and write out the reformatted notebook to standard out. And additionally, rather than working with the JSON directly, I've made use of the MB format library. So this is a really neat little library that just understands the Jupyter file format, knows about changes between schema versions and things, so you don't need to worry about that. Similar to the file save hook, if we wanted to use this directly, we'd need to copy this code somewhere. We'd also need to work out how to install the git clean filter in our repositories, which I've not covered. Luckily, there are a ton of projects floating around on the internet that automate some of this for you and a bit more robust than this very simple code. So a nice example that's quite popular is called MB Stripout, which is written by Florian, one of the organizers of PyData London. And it's very simple. You can install it from PyPy. It's all written in Python. And then from within a Git repository, if you call MB Stripout -- install, that'll set up the filters for you automatically. And now every time you commit a notebook, its output will be cleaned. The nice thing about this is super easy to remember. And additionally, if your repositories or projects have a convention, for example, having like a script called setup.sh that maybe creates a virtual environment and installs some dependencies, then you can just tack these couple of lines onto the end, and everyone who joins your project when they set up the project will get this for free. So that's much easier than having to pass code around. So that's how we could automatically strip output, clean our notebooks before we commit them in a more automated way. And now we've cleaned up our output, maybe we're ready to commit it, push it so that someone else can review it and decide if they want to merge it. So the person reviewing that notebook pulls down the code that you've written from GitHub, for example, and looks at the diff. Although we've, in some cases, cleaned output, if they're looking at the diff, they're still looking at the diff from the JSON. So for example, in this block at the top, although it's Python, it's not quite Python, because everything's wrapped in double quotes, and I've got these new lines at the end. And additionally, if I had any double quotes inside my Python, then they'd be escaped. So it's a bit difficult to read. We prefer it if we could just directly read Python code rather than the JSON escaped version. And secondly, in these cases, for example, like documentation or tutorials, the reviewer is still going to see a bunch of base64 encoded gibberish rather than the image, which I don't know about you guys, but I definitely couldn't tell what's changed in that plot. So thankfully, this is where tools can help us, and there's a really, really cool one. And this is MBDime. So MBDime is a tool from the fine folks at the Jupyter project. It stands for Notebook Diffing and Merging, and it basically does what it says on the tin. So it's a set of tools for diffing and merging Jupyter notebooks, and it comes with Git integration out of the box. So some of the cool stuff it can do, MBDime knows when you're viewing a Git diff in a terminal, and in that case, it'll truncate this base64 output because it knows it's not useful to you in the terminal. It'll use context-dependent diff tools for inputs and outputs. So this means it knows that I want to view a diff of an image, for example, by seeing the before and after image next to each other, whereas I want to see a diff of Python code in the sort of standard Git way with interleaved lines with red and green. It can render those image diffs in a browser rather than in a terminal. And then some of the things that you would otherwise have to deal with manually when you're merging different branches, like resolving conflicts between cell execution counts or other metadata, it knows how to deal with automatically. So rather than seeing the raw diff of the JSON, if our collaborator who was reviewing our change now had MBDime installed, they could call MBDiff. And in this case, this is much nicer to look at, and it's much more useful. So MBDiff has split up our changes into chunks, and these comments preceded with the double hash tell us where it comes from in the notebook. So cell 14 is the output part of the cell. And the second group of changes you can see is a base64 encoded image. In this case, it's just truncated that because it knows it's not useful and just given us the hash. Whereas the very final change is what we're actually interested in. It's the Python code change. And here we've got a really relevant diff that's shown us the exact keyword arguments that have changed. So this is much more useful and much more likely for one of my collaborators who are sat at the front to actually want to review and merge. So in this case, maybe I'm happy with the code, but I actually want to see what the result of the image change is, and I don't want to have to learn to decode base64 in my head. In this case, I can use MBDiffWeb, and this will open a web browser and present me with a really nice graphical visual diff in the browser. So I can see here, for example, that I've changed the keyword argument face color to give it the image a darker background. And then MBDiff also renders the actual two different images, so I can see exactly what's changed. It's super useful. So similarly to MBStripper, MBDime is pretty easy to install and get configured. Again, you can install it from PyPy with pip. To install the various Git configuration in your current repository that will make Git use this automatically, you can just call MBDime config git --enable. And once I've run that MBDime config git step, when I run git diff, it will automatically use MBDime for those diffs for Jupyter notebooks and the standard git diff tools, for example, for Python source code that's in the same repository. Secondly, say my code was super awesome and everyone on the team agrees that we should change all the plots to be red. In this case, they might want to merge my changes, so they run git merge. Now, typically, if the two sides have changed, so for example, the remote code on GitHub and the local code have diverged, then Git will try and merge these. And often with Jupyter notebooks, because of this structure, this will go quite badly wrong. And the result you'll end up with is no longer a valid notebook and it's no longer valid JSON. And Git will essentially dump you into an editor like Vim and tell you to sort it out for yourself. And that requires superhuman abilities that I don't think very many of us have. But if you've configured MBDime in this way, git merge will automatically use one of the MBDime tools to insert conflict markers in the file in a way that the file remains a valid Jupyter notebook. So it's still valid JSON, and it still follows the Jupyter notebook schema. And then you can use a tool that gets distributed with MBDime called the MBDime merge tool. Give it the name of the notebook with the conflicts. It'll open up this freeware view in your browser. And you can just go through and click which side of the merge you would like to include in each case. Really graphical and really easy to use. So there are a few of the things I think hopefully will be able to help you if you use Git and Jupyter notebooks together a lot. So just to reiterate, I think the top tips to take away in sort of order of complexity, but maybe reverse order of value. Firstly, use git add-p and then you can only stage the relevant changes, ignore metadata noise or other changes. Secondly, use a Jupyter file save hook or a git filter provided by something like MBStripout if you want to clear output or metadata automatically without having to think about it and remember to do it manually each time. And then finally, check out MBDime if you're interested in being able to more usefully diff and merge notebooks. Just as a final point, so my day job at ASI is building a data science platform called Sherlock ML. If you're interested in Jupyter notebooks and Git and Python and data science, for which my prior is quite high given that you're here, Sherlock comes with MBDime, for example, pre-installed and pre-configured. So if you're interested in giving it a try, just check it out and give it a trial. Secondly, if you're interested in seeing this in action, one of my colleagues, Pascal, is giving a talk at 11:30 where he's going to pretty awesomely live code a Jupyter widget from scratch on Sherlock ML. So I encourage you to go along to that. Thanks.
Okay, we've got time for two very short questions, which are questions.
It feels a bit like you're kind of scratching your head like this. Yesterday there was a talk on a version control system. Why not just do a custom version control system for these JSON files?
I think it's beyond my abilities. I'm not Linus. It also means that we wouldn't be able to, so for example, in repositories, often you'll have a mix of Jupyter notebooks and Python source code or other languages, for which Git is actually really well suited. So you still want to use Git for those other tools. And also because Git's got massive adoption, it means that a lot of people already know it, a lot of data scientists and engineers already know it. So I think that's why I prefer the approach of making Git easier to use because people are already familiar with it versus re-implementing another version control system that would be like really well suited to Jupyter notebooks, but it's a lot of cognitive overhead for people to use.
Thanks for the talk. We've got a very basic process for solving this problem, which is Dropbox and manual reviews. To what extent could this add that much value if syncing files, Jupyter notebooks on Dropbox, and then the reviewing party looking their way through them? How could this make that much of a difference in that with our simple use case?
I think, well, in the case that you have like large notebooks, the reviewer in that case, I guess, they see the old notebook and the new one, and then they just have to visually themselves go through and see what's changed. Whereas with something like MBDiff and GitDiff, it's actually going to point out to you exactly what's changed. You don't have to visually recognize that. Also, if you're using Git, you can host your code on like GitHub, for example, make use of tools that integrate that, like CI tools like Travis and things, whereas if you're using Dropbox, for example, that's not really possible. But certainly if you're doing like a smaller project and there's only a couple of people, so you have very easy communication, certainly maybe simpler solutions work.
Okay, thank you very much. That was a very interesting talk. Coffee and maybe Welsh cakes are being served down here, but I'm not going to make any promises about the food. So thanks once again, Scott.
Thanks.